For years, the nations of Earth have been protected against enemies both big and small by a man of iron, Tony Stark, a wealthy industrialist clad in a cutting-edge and ever-evolving set of powered armor, one that is capable of turning your average genius billionaire playboy philanthropist into a being capable of throwing hands with gods, monsters, and even a rampaging Hulk. But how does this armor work, what's inside it, and what exactly is it capable of? All questions that we should be able to answer today, as recently our Lortor spaceport security team intercepted a rather strange carry-on item coming through security, a collection of the famous Iron Man armored suits. After confiscating the prohibited items, we sent it over to the guys and gals in our R&D team, ready for them to break down and subject to a few tests designed to give us a better idea of what's inside the armor and just how fast, tough, and strong this suit is. And, well, they're pretty impressed with this armor's capabilities. It's a real marvel of modern engineering. At the base of the armor, beneath its iconic red and gold shell, is an advanced network of articulated mechanisms, forming an inner exoskeleton layer. This consists of a series of metal structural components, such as boots, gauntlets, and a chest piece, fitted to the creator's measurements, forming a metal lattice around the user's form, and providing cushioned support for the user's body throughout the armor at points around the back, neck, hips, and legs, to provide comfort and protect against injury. This exoskeleton also provides the means through which you would move the armor. Now, in earlier versions of the armor, like the Model 3 that we currently have here, it seems the suit is moved via motorized servos and linear actuators at the joints, tiny electric motors and piston-like devices, which bend and extend limbs and fingers or push and pull to create movement. These mechanisms bear the weight of the armor's heavy frame, and magnify the user's strength significantly, using advanced motion sensors and feedback systems to react to the user's slightest movements in milliseconds, so that when you try to move an arm or take a step, the armor moves in unison, turning your effortless movements against the frame into fluid motion. To help keep the armor upright, level, and moving in a fluid manner, it would seem the armor may also contain an array of gyroscopes, accelerometers, and stabilizers, all designed to monitor and adjust the armor's movements. Just as a human's inner ear provides balance, the suit's gyroscopic stabilizers would detect if the armor is tilting or off balance, and the exoskeleton can automatically shift position to compensate. For example, when landing from a jump or flight, the sensors and onboard computer adjust joint stiffness in real time, absorbing impact while dozens of micromotors and actuators make minute adjustments to joint angles every second, all to tweak the posture or redistribute weight to prevent toppling. The armor also likely employs force sensors in the limbs to detect external pressures and adjust torque accordingly, so that the suit can both catch a car hurtling through the air and firmly shake a hand without accidentally obliterating it in a brutal mess of gore. In later models, it appears the technology used to control the armor was improved dramatically, including the addition of direct neural interfaces, shifting from physical movement sensors to cybernetic control, meaning the armor can sense and interpret your own brainwaves and respond in an instant. Now, there seems to be a lot of inconsistencies around how physically strong the armor is. It all seems to depend on which version of the armor is being tested, and how much power the armor has at the time. From the tests on these suits that we conducted down in our lab, the armor seems to be in the 60 to 100 tons range, meaning the armor could easily go toe-to-toe with some heavy hitters, or lift, say, a tank. Above the exoskeleton lay the suit's armored plating, the main protection for the wearer against whatever they come up against. The earliest suits feature armor plating made of steel alloys and chrome-plated titanium, which, while proving fairly durable, have also shown themselves to be susceptible to freezing over in certain conditions, making them inadequate for use in an armor that needs to fly at high altitudes. To get around this issue, a new material was used for later marks of the armor, coming in the form of a gold titanium alloy used elsewhere on military satellites. This material is 4 times stronger than pure titanium, and it's also relatively light while still incredibly strong. But how strong is it? Well, to find out, our team subjected the armor to a number of different tests to see how much punishment this armor could take from various sources of damage. We began with live fire tests using conventional firearms, and the armor held up remarkably well. Handgun and rifle rounds sparked and ricocheted harmlessly off the gold titanium alloy, leaving only minimal cosmetic damage. Stepping it up a bit, our team unloaded heavy caliber .50 Browning machine gun rounds into the suit. Yet, while they slammed into our armor with thunderous clangs, and they may have staggered the suit somewhat, the armor remained intact. Taking it even further, we fired one of Stark Industries' own rockets at the suit, which it survived with very little damage. A pneumatic hammer was used in our lab to deliver a series of strikes designed to mimic superhuman punches to the chest plate. The armor held up against these individual strikes, however, as the levels reached the higher limits, around the mark of notable heavy hitters like Thor, Thanos, and the Hulk. The chest plate did begin to buckle, indicating that certain high-level foes could cause significant damage with continuous strikes or sustained pressure. Next, we tested the plating against edged weapons using a vibranium blade. Glancing strikes and one-off hits left little damage. However, repeated strikes at the same spot did begin to compromise the armored shell. Nonetheless, encouraged by these tests, the team decided to bring out the big guns, pitting the armor against more exotic weaponry from other universes, and they were all too eager to crack out a pair of Halo Covenant plasma rifles, which we used for testing the armor against bolts of superheated plasma, commonly used as a projectile in other universes. Now, the titanium gold alloy seemingly has a melting point of between 1000 and 1700 degrees Celsius. Gold melts at 1064 degrees, whilst titanium melts at 1668 degrees Celsius. Meanwhile, the superheated plasma from these rifles measures in at temperatures we believe to be at a minimum of 3000 degrees Celsius. So when the neon blue bolts slammed into the chest plate, the first blast splashed off, leaving a charred splash of damage where the armor began to melt upon impact. Successive blasts began to turn the armor into molten slag, boiling and bubbling as a puddle on the floor, meaning we had to write off that particular suit and move on to another one to test further durability. Elsewhere, the armor proved to be hardened against EMP attacks, and it's atmospherically sealed with an internal oxygen supply, so you won't suffocate when taking a joyride to the edge of space or a dive into the ocean depths. To assess the armor's environmental resistances, we took it out of the lab on a field trip to the Star Wars universe, a place rich in planets with diverse environments that could provide us ample opportunities to test how the armor fares in extreme environments. When testing the suit's pressure resistance, our team plunged the armor deep into the famous oceans of Naboo. Initially, the armor held up well, operating fine at depths of over 50 feet, but as the armor plunged lower and the pressure mounted, microfractures began forming in some joint seals, and the plating started to buckle underneath the pressures of the ocean, meaning that some rather helpful local Gungans had to help us retrieve the suit long before it reached ocean floor depths of 6,000 meters. It did, however, fare much better when left out overnight on the icy tundras of Hoth, where temperatures regularly fall to below -60 degrees Celsius. Here, the suit's internal temperature controls kept the user warm and toasty, whilst the gold titanium alloy maintained structural integrity under the remorseless cold of the ice planet. And finally, we jettisoned the suit into the vacuum of space, where its radiation shielding kept the wearer protected from the radiation levels encountered in space. The armor would be useless, however, without its power source, and such an advanced piece of technology has a pretty large power requirement. The solution to the armor's ravenous power consumption lay in the arc reactor, an innovation more impressive than the suit itself. Housed initially in Tony Stark's chest, the reactor would later move to the chest of the armor proper, and it's, as far as we can tell, a miniaturized fusion reactor that relied on the rare metal palladium to generate insane amounts of power. We estimate that this early mini-arc reactor's output is around 3 gigajoules per second, equivalent to burning 120 barrels of oil a minute. The palladium used by the arc reactor has been swapped out in later models for an unnamed new element that our scientists could not identify. However, we observed that this new element does not deteriorate as quickly, and has a massive power output increase. The armor has impressive flight capabilities, made possible due to a series of repulsors on the hands and feet, which draw upon the arc reactor energy to generate highly controlled directional force that, when combined with stabilizers and thrusters around the armor, allow for vertical takeoff, hovering, and high-speed forward flight. In our tests, earlier iterations of the armor were measuring in at speeds of at least Mach 2, capable of around 1,500 miles per hour, meaning they're more than fast enough to outpace modern fighter jets, and travel from Afghanistan to Malibu in around 2.5 hours. With later marks of the armor, the speeds were registering off the charts for such a small manned vehicle, easily traveling at hypersonic speeds of Mach 5 and above. That's well over 6,000 miles per hour, meaning it could travel from New York to London in just over half an hour. And we weren't able to substantiate this ourselves, but it's been reported that individual segments of the armor have been shown to travel 832 miles in under 2 minutes, equating to high hypersonic speeds of over 24,000 miles per hour. Given these mind-boggling speeds that the armor travels at, we really started to wonder, how does the suit deal with the problems posed by G-force? After all, human bodies cannot withstand sudden high-speed acceleration without serious damage. In theory, the wearer should be turned into a bloody pile of mush inside the suit when accelerating and maneuvering rapidly, but we don't really know how the suit prevents this. It appears that there's some kind of inertia dampening technology within the armor that allows it to counteract the force of acceleration, preventing internal organs from slamming against the ribcage when changing speed rapidly. One theory is that the arc reactor generates a repulsor field inside the suit, cushioning the pilot against sudden changes in velocity, counteracting acceleration by exerting an equal force in the opposite direction. The suit's repulsors are also part of the armor's broad suite of weaponry, serving as its signature weapons. The repulsors can fire concentrated pulses of energy that hit with massive concussive force. They can be tuned from non-lethal, like a shove, to destructive, meaning you can use the repulsor blast to knock enemies off their feet, or blow holes through obstacles. Other common weapons found in the armor include small guided missiles hidden in compartments around the suit, usually on the shoulder or forearms. But don't let the size of these missiles fool you. These mini rockets pack a punch. A salvo of them can be used to take out multiple targets, or a singular larger one can be launched that's powerful enough to destroy a tank in a single volley. They're also smart munitions, self-guided to chase moving targets. The unibeam is a powerful beam of energy fired directly from the arc reactor housing on the suit's chest. It channels a huge amount of the arc reactor's power into one devastating blast, 10 times as powerful as a repulsor blast. In testing, it proved more than capable of one-shotting heavy targets and completely obliterating structures made of titanium. The unibeam does, however, require significant power to use, so it's best saved to help finish off a fight. Finally, a more recent addition to the suit are high-intensity cutting lasers built into the wrist or gauntlet. Again, these require significant power to use, but have proved capable of slicing through enemy robots and concrete buildings like butter, whilst also proving useful on lower power settings to help weld metal together. At the top of the armor lays the helmet, which serves as the physical command center. Here, the suit's advanced artificial intelligence, be it Jarvis or Friday, interfaces with the wearer. They manage so many functions that without them, a human probably couldn't operate the suit at full capacity. The AI provides a sleek heads-up display inside the helmet, overlaying info like enemy locations, incoming projectiles, suit power levels, and probably even some Subway Surfer brain rot if you like. When you're flying and multiple bogies are on your tail, The AI will be calculating intercept courses, highlighting danger zones on your visor, and even auto-adjusting your flight path to avoid collisions. In combat, it can auto-target repulsors or guide your missiles, and you can even have a nice chat with it, asking for suit status updates or for tactical advice. Like pretty much everything with this armor, the way it's equipped is constantly innovating. Initially, the standard way of putting this armor on involved the machine-assisted assembly of individual interlocking pieces, such as boots, shoulder pieces, and the upper exoskeleton, which were screwed into one another and had the armor plating attached over the top. This process would be improved to make it less time-consuming. Various updates included a portable emergency version of the suit, which when activated and placed upon the chest, assembles itself around the wearer, a self-propelled capsule version of the suit which can be called to the wearer, lining up with 2 bracelets and unraveling itself around the user, and even individual pieces which can fly to the user, building and connecting to the wearer on the fly. Another neat trick is the armor's sentry mode, where you can have the suit operate autonomously for short periods, with the AI piloting the armor like a drone that can fly to you, ready for you to step into. There also exists many different variants of the armor that differ greatly in purpose, composition, and functionality. Now, we weren't able to get our hands on any of these for study today, but we have been able to analyze from afar 2 of the most notable variants of the Iron Man armor, the Hulkbuster and the Nanotech armor. The Hulkbuster is an extra-large, extra-powerful armor created as a safety measure in case the big green mean machine, the Hulk, ever needed to be subdued. Accompanied by a nice little cage for the Hulk, this armor is an enormous bulked-up exoskeleton deployed from orbit that fits over a regular Iron Man suit like an attachment. Durability-wise, it is layered in thick composite armor and can soak up hits from the Hulk that would obliterate a normal Iron Man suit, meaning the Hulk can strike the armor and rip pieces off, but the Hulkbuster will keep functioning, fully expecting the armor's integrity not to last long against such a powerful combatant. The modular design of the armor allows the wearer to call in replacement parts from the suit's accompanying Veronica satellite. A number of other improvements have been made to help the wearer face off against such a powerful foe, including significant enhancements to the suit's strength, meaning it can deliver punches strong enough to send the giant sprawling across city streets, improved power to the suit's repulsors, and improved thrust capabilities, allowing the wearer to pick up and fly with the Hulk. These enhanced capabilities were all made possible thanks to over a dozen arc reactors distributed throughout the frame. Other tools at the armor's disposal to help deal with the Hulk include hydraulic rams on the arms, allowing the fists to deliver a pneumatic jackhammer beatdown. Tranquilizer gas dispensers and arm restraints were also used to help trap the Hulk and keep him attached to the armor, because despite its name, the Hulkbuster isn't really designed to defeat the Hulk. Its real purpose was more to distract and pacify, to move him away from population centers. By far the biggest advancement in the armor came with the invention of the Nanotech suits. They are made out of nanoparticles that can configure on the fly, making the armor incredibly versatile and portable. The entire armor is stored in a small arc reactor that can be worn on the chest. With a tap of the arc reactor, the billions or trillions of nanoparticles flow out from the armor, assembling themselves around the user's form in seconds. The nanotech nature of this suit means that it has no fixed shape. It replaces the bulky gears and servos of the old armor with artificial muscle fibers that act as a second skin. The suit can generate new structures and weapons on the fly by reallocating its nanoparticles. Need a sword? Well, the arm can morph into a blade. Need to up your repulsor power? The suit can form a cannon around your hand. The offensive and defensive possibilities are near endless, and when part of the suit is damaged, the armor can shift nanites from one area to patch up more vital areas of the suit. Despite being made of so many tiny pieces, the nanotech suit is still tough. The nanoparticles bond together to form a solid armor surface that's just as durable as previous suits, if not more so. When formed into a shield, the armor has been seen to take direct hits from the Power Stone, and it's still held together. It's by far the fastest armour too, seen achieving Mach 9 speeds by using the nanobots to turn the suit's legs into one giant booster, making the suit the fastest piloted man-made object in existence. The Iron Man armour isn't just a suit, it's an idea in motion, an ever-evolving testament to human ingenuity and unwillingness to back down from a challenge. There is no final form, no perfect iteration, because each battle, each enemy, each lesson learned forces the suit to change, improve, and push the boundaries of what's possible. So, if you were designing your own Iron Man armour, what would you add to it? And of all the countless variants out there, which one would you most like to own? Make sure to let us know down in the comments, and don't forget to subscribe and ring the bell to join us again soon. Until then, catch you next time.